Sixth grade, so this is my second video for this week. I know in the last video I said there's only going to be 2 this week, but after looking through this content, I'm deciding to make another video after this. If we try to do everything in one video, it would be very long, so I'm going to break it up a bit for us. So, we are going to talk about how to name compounds. So we're going to be doing this 2 different ways. We're going to be talking about one way in this video and the other way in the next video. So, naming compounds. To start off, what is a compound? Well, a compound is a pure substance that is combined with 2 or more elements, but they can only be separated through chemical means. So, you probably encounter compounds every single day in your life, so try to think of a few. I'll give you a few seconds. Alright, so some examples would include water, which is H2O, carbon dioxide, CO2, salt, NaCl, baking soda, NaHCO3, sugar, C12H22O11, and flour, which is C6H10O5. Those are just a few. There are tons that you probably encounter every single day. So there are different ways to name compounds. It all depends on what elements make up that compound. So there is a compound that is called binary ionic. So binary ionic is between one metal and one nonmetal. The other one is called binary molecular. So I know they both have the same first part of their name, binary, but the difference between them is whether it says ionic or molecular. So ionic, one metal and one nonmetal. Binary molecular is between 2 nonmetals. So we're not going to be talking about any that is just between 2 metals. It's either one metal, one nonmetal, or 2 nonmetals. And there's different ways on how these follow rules, and we're going to talk about each one. So, the periodic table. You are going to need it for this a lot, because you're going to need to know what elements are metals and which ones are nonmetals. Remember, on the periodic table, all of the metals, except for hydrogen, are found to the left of the stair step on the periodic table, and I have one here with me. So remember that stair step is that blue right here. So anything to the left, these are metals, except for hydrogen. And then nonmetals are found on the right. And our metalloids are the ones that fall along that stair step here, but that's not that big of an issue. It's more so knowing where the metals and nonmetals are. So our first one is how to name binary ionic compounds. So remember, binary ionic are between a metal and a nonmetal. That's why you need your periodic tables. That way you know which is which. What you will do is you are going to name the first element. So you're just going to say its name. Anything from groups 1, 2, 3, and 13, zinc, candium, and silver. We're not going to do the transition metals, however, like I said before. And then you're going to name the second element. And then for this one, you're going to change the ending suffix to "ide." And you're going to do this on the last vowel of the word. And I know it might be hard to determine how to do it, so if we have a little bit of trouble doing this for the first week, that is completely fine. So, a closer look on how to do it. First, you write the first name of the element. So we have Mg, which is magnesium. You write the root name of the second element, or you can just write down the second element however you want to do it. So they have Br, which is bromine. So they are taking it from that vowel there, and they're cutting it off. So you have brom. You're going to add the suffix "ide" to the root name, so brom plus "ide" equals bromide. And then this is the name of the compound, so you take that first element and combine it with that one. So you have magnesium bromide, MgBr2. So some more examples, and just know for this one, you might see some subscripts, which are the numbers that are down below. We are going to completely ignore those for these. So we have NaCl, that is sodium chloride, CaO, that is calcium oxide. So with oxygen, you're going to cut it off where the Y is, so it's not going to be oxygenide, it's just going to be oxide. Al2S3, like I said, we are going to completely ignore those numbers for now, but they will be important for our next naming. That is aluminum sulfide. MgI2, magnesium iodide, and some practice. So we have LiCl, so Li is lithium, Cl is chlorine, so we just name the first element, which is lithium, and then Cl, remember I just said it's chlorine, but we need to change it so that way it says "ide" at the end, so it's going to be lithium chloride. So the "ine" you just change to "ide," chloride. We have CaSe, so our first one is calcium, Ca, so we're just going to name that calcium. And then next we have selenium, I believe, so it's going to be selenidide. Selenide, sorry. Our next one is Ga2S3, so our first one here is gallium. So we're just going to name that gallium. Going to completely ignore those numbers for now. And then our next one is sulfur. So sulfur will change to sulfide. We have MgF, so we have magnesium, and then fluorine. So we're going to just name magnesium. And fluorine is going to become fluoride. So that's our binary ionic compounds. Next we have binary molecular, and remember these ones are between two non-metals, and we are going to include the numbers this time as well. Two non-metals, like I just said, and like I said, it's a bit different. You will have prefixes this time. So last time we had a suffix, so that goes at the end of the word. A prefix comes before the word. So our prefixes are going to be those numbers that we were ignoring before. So that's telling us how many of each element there is. So our prefixes that we are going to use are mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. So I would highly advise that you probably write these down somewhere. If you have a periodic table, maybe write them on the back of it, or just write them on a separate sheet of paper because you are going to need to remember these. Alright, so a few rules with our prefixes. The only time the first element is going to get a prefix if it has more than one. So whenever you see something like NaCl with no number behind that Na, you are going to assume that it has at least one. So if it has one, you are just going to write the name of the element. You don't have to write any sort of prefix before it. Excuse me. You don't have to write any prefix before it. So you will write a prefix if it has like 2 or more. The second element is always going to get a prefix. No matter if it only has 1 or more, it will always get it. And like last time, that element is always going to end in "ide" as well. Just like it did last time. So, some practice. Since there's no prefix in front of C, we are going to assume it is 1. Look at the number behind O. This is how many oxygens there are. So we have CO2. So what is the prefix for 2? That is di. So carbon, since it has no number here, we are just going to assume it's 1. So it's not going to have any prefix. Oxygen, since it has 2 here, it will. So we have carbon, and then because 2, dioxide. Remember, it has to end in "ide." So another example, we have CO. So there's no number here, so there's going to be no prefix in front of it. And then there's also no number here as well. But remember, this second element is always going to have a prefix if it is a binary molecular compound between two nonmetals. So, no number, so we have to assume it's 1. So the prefix for 1 is mono. So for carbon, remember, no prefix, it's just carbon. For oxygen, there's a prefix, it's mono, and remember we need to end in "ide", so it's monoxide. So we have carbon monoxide. Another one, we have N2O4. So this time we do have a number here, so we do need to have a prefix in front of nitrogen. And then oxygen, we have 4, so we need to think of what the number is for 4, and then write that down. So for nitrogen, it's going to be dinitrogen, so di is 2, and then for oxygen, it's going to be tetra for 4, oxide. Sorry guys, my nose is kind of runny. Alright, we have HO2. So you probably know this one as water, and you might just say it's H2O, my mistake last time, sorry. So hydrogen does have a number behind it, it's 2, so think of what the number is for 2, the prefix for 2 is. And then oxygen, it has no number, so it's 1, so think of what the prefix for 1 is. So H2O, water, its actual name is dihydrogen monoxide. Dihydrogen monoxide. Maybe go tell your parents if you're drinking some water, like, hey, I'm drinking some dihydrogen monoxide. And then we have CCl4. So we have carbon, no number, so we don't have to worry about a prefix. Cl, we have 4, so think about what 4 is, and then how it should end in "ide". So we have carbon, tetrachloride. Tetra for 4, ide for the end of it. So we learned how to actually write them down by seeing the symbols of the compounds along with any subscripts if necessary. Next, we are going to be looking at the names of compounds and how to write them in the symbols with the subscripts. So what I'm going to have you do now is I'm going to have you do this Google form to see how we were understanding this. It says, please complete this form after watching the Name Compounds 1 video. If you do poorly, redo it for a better grade. So it's going to ask you some questions like about the prefix, the staircase, the binary and molecular, and then it's either going to ask you what kind of compound is this, and they'll give you one, and you have to say it's either binary molecular or binary ionic. And then what is the correct way to write out this compound? So it's going to give you some different options. You need to remember that if it is a binary ionic compound, that is between let me find it here for you. Binary ionic is one metal and one nonmetal, and binary molecular is between two nonmetals. So every time you see one of these compounds, you need to be looking, is this a metal or a nonmetal, and is this one a metal or a nonmetal? If you do that, then it will help you a lot. If you are just guessing, then you will probably get it wrong. Alright? So I'll see you guys in the next video on how to write the symbols and subscripts. Alright, see you guys then.